Hello, I am Professor Yogesh Thakre. Welcome you all for an introductory lecture on the topic transistors of the course Electronic Devices and Circuits required for the students of second year undergraduate engineering in electronics and telecommunication domain. Friends, transistors are capable of impedance transformation, hence rightly named as transistors, that is transfer of resistance. Friends, all the logical events or processes can be designed using switches. Data transfer can occur through switching, and also data processing requires switching. The switching requires impedance transformation that is available with transistors. Hence, transistors are the base for every electronic circuits that require switching action. There are many applications of transistors. They are used in electronic switches or regulators like fan regulators. They are used in mobiles, smartphones, televisions, set-top box, radio, automobiles, all types of computers like PCs, laptops, tablets, CD or DVD players. Everywhere for automations, and these applications are never ending. Everywhere one can devise use of transistor. With increasing number of transistors for implementation of applications, integration of transistors advanced semiconductor technology from small scale integration to ultra large scale integration. As shown in 1970, Intel 4004 processors required around 5000 transistors, whereas Intel dual core processors around 2005 required to integrate 1000 million transistors. Jordan Murray, co-founder of Fairchild Semiconductor, was correctly predicted that number of transistors needed will be doubled every 2 years, and that's why integration technologies also have to change rapidly. With increasing number of transistors required for integration, the transistors technologies are also evolving. Use of inorganic semiconductors like silicon, germanium, gallium arsenide, indium phosphide in transistor manufacturing is becoming a old technology with the advancing organic semiconductor industry. Organic semiconductors are made from carbon, hydrogen, nitrogen, oxygen, sulfur like atoms, and support molecular electronics. Organic semiconductors are emerging as competitors since they support molecular electronics, where Each molecule is a device. This supports increased level of packaging density, that is, number of transistors on single chip that can be integrated. Also, organic semiconductors offers flexibility and low cost as well as lightweight, and that's why in coming days organic semiconductor industry will be the competitors for existing silicon based technology. Already organic light emitting diodes, organic transistors are existing in the market. Let us look towards the types of transistors. Dear friend, the transistors are classified as bipolar junction transistors and field effect transistor, that is FET. Bipolar junction transistor, that is BJT, is commonly referred to as transistor. These are further divided as NPN transistor and PNP transistor, whereas FETs are divided as junction field effect transistor and MOSFET, that is metal oxide semiconductor field effect transistor. These are further divided as N channel and P channel junction field effect transistor, whereas MOSFETs are divided as depletion MOSFET and enhancement MOSFET. These are further divided as N channel and P channel DMOS as well as EMOS. Dear friend, we must remember the inventors of transistors, due to whom the world has facilitated a lot. Dr. Shockley, Dr. Bardeen and Dr. Breton together invented transistors, that is bipolar junction transistor, in Bell Lab. Whereas Dr. J.E. Lenfield patented the idea of FET as well as FET well before bipolar junction transistor in 1930, but could not be practically realized. Oscar Hill, together with William Shockley and team, have given a great contribution to the development of field effect transistor. But with the advent of MOSFET by D. Kong and M. Atala in 1959, the MOSFET has taken, or BJT for processor and digital electronics industry, very rapidly. Nowadays, all the processors are based on FETs due to many advantages for bipolar junction transistor. Let us look few differences between bipolar junction transistor and FETs, because of which FETs are considered to be more advantageous for large scale integration or ultra large scale integration. In bipolar junction transistors, conduction occur because of majority charge carriers as well as minority charge carriers, whereas in FET only majority charge carriers are responsible for conduction, and that's why they are called as unipolar devices. There is no thermal runaway in field effect transistor compared to that of bipolar junction transistor. Bipolar junction transistor possesses negative temperature coefficient as compared to positive temperature coefficient in FET. Power consumption in field effect transistor is very less compared to that of bipolar junction transistor. Power consumption in bipolar junction transistor is mainly due to minority charge carriers. Packaging density of bipolar junction transistor is low as compared to field effect transistors. Input impedance of bipolar junction transistor is also low since it requires forward bias to input circuit, whereas field effect transistor possesses high input impedance because of oxide layer that is available in MOSFET, or otherwise reverse bias that is provided to the field effect transistors. Bipolar junction transistors are linear in nature, which can be easily understood by this equation IC is equal to beta times of IB, whereas field effect transistors are non-linear in nature, wherein the conduction current ID is given as IDSS into 1 minus VGS divided by VGS for depletion MOSFET and junction field effect transistor, whereas ID is equal to K VGS minus VTH square for enhancement MOSFET. That is, it follows the square law. Controlling parameter for this is in BJT is current, whereas controlling parameter in FET is voltage. Bipolar junction transistor possesses narrow frequency response in kilohertz, whereas field effect transistors possesses broad frequency response in megahertz. The speed of operation of bipolar junction transistor is slow, whereas field effect transistor possesses a greater speed. Therefore, field effect transistors becomes a choice for many of the or all the processor applications and leading the industry, and especially the MOSFET or CMOS devices is ruling the digital world. Thank you.